Hello friends, myself Dr. Nandakumar Raubale from College of Engineering Ambazogai is going to deal with fluid mechanics. So in previous lecture we have discussed about the numericals on manometers. Today we are going to discuss the introduction to hydrostatic forces on the surfaces. In that we are going to discuss the definition of total pressure, then what is the center of pressure, and cases of submerged surfaces, and vertical plane submerged in the liquid, and numericals on the vertical surface submerged in the liquid. So now let us see what these hydrostatic forces are. So hydrostatic means the fluid at rest. Static is nothing but at rest. Hydro means a fluid at rest. So the forces acting on due to the stagnant substance, that is the liquid or fluid, is known as a hydrostatic force. So these hydrostatic forces are acting because of fluid at rest, where we cannot find the relative motion between the fluid layers. Say for example, two adjacent layers are there, layer number 1 and layer number 2. So there is no relative motion between these two layers of a fluid. Then if there is a no relative motion between the fluid layers, that means there is a no velocity gradient. There is no velocity gradient means as we have seen, change in the velocity with respect to y, dy, du by dy is going to be 0. So if we have velocity at this first layer as 0, then velocity at second layer is also 0. There is no relative motion with respect to the distance y. So there is no change in the velocity, that is there is no velocity gradient. If there is no velocity gradient, then shear stress tau is equal to mu du by dy is also going to be 0. That is, there is no shear stress between the layers of a fluid. So there is no shear stress between the adjacent layers of a fluid. Then the forces will be acting in such fluid which is stationary or fluid at rest because of two reasons. One is the forces that will be acting because of pressure of the liquid, and second one is the forces acting due to the self weight of the liquid. So one is the pressure of fluid normal to the surfaces because of only fluid pressure, and second one is because of gravity or self weight of fluid particles. These are the two reasons because of which forces will be acting in a static fluid, so fluid which is at rest. Now we'll see what this total pressure and center of pressure is. So this total pressure is nothing but the force exerted normal to the surface. Force exerted normal to the surface by the fluid when the surface comes in contact with the fluid. The surface either may be a plane surface or it may be a curved surface. When the surface comes in contact with the fluid exerts a force on it, and that force which is acting on the surface is going to be normal, means it is going to be a perpendicular. Say for example, this is the surface, and if the fluid is kept above it, so this fluid is making or exerting some force on this area A. So this force is acting perpendicular normal to the surface. That is a total pressure. So here the term total pressure is nothing but a force. It is not a pressure, actually it is a force. So unit of this total pressure is Newton. So unit of force is Newton. So this is the term used pressure does not mean that its unit is Newton per meter square. So specifically the total pressure is not a exactly pressure, it is a force. It is not a pressure, it is a force, but this force is termed as a total pressure. So total pressure is nothing but a force, not a pressure. So unit for pressure is Newton per meter square and unit for force is Newton. So this total pressure has got the unit as Newton. So what it is the normal force. Normal force in the sense it is a perpendicular force exerted by static fluid. Which kind of fluid? When fluid is at rest on a surface either plane or a curved. So surface may be plane or curved when fluid comes in contact with the surface. So that force is known as a total pressure. That is known as a total pressure. Then what is the center of pressure? So center of pressure is nothing but the point at which the total pressure acts. Say for example, this is the surface, vertical surface, and force acts at one point P. So the point at which this force total pressure acts is known as the center of pressure. So center of pressure is nothing but the point or location at which total pressure acts is known as a center of pressure. So it is the point at which total pressure acts on the surface. Now there are different cases of submerged surfaces over which the hydrostatic force acts, or total pressure acts. So first case is vertical plane surface. There are four cases. First one is vertical plane surface, in the sense the plane surface which is submerged in a liquid which is in vertical position. Then second one is horizontal plane surface. If the surface is horizontal and it is submerged in the liquid, then the forces acting on horizontal surface can be calculated. Third one is inclined plane surface. If a plane surface is inclined and submerged in the liquid, then we consider it a third case. And fourth case is curved surface. So it can be a curved surface like this, or it can be a curved surface like this. Whatsoever may be the shape of curvature. So that surface, if it is submerged, so how the total pressure acts and where this total pressure acts, that we have to find out. Now we will see the first case, the vertical plane surface submerged in a liquid. Now let us consider one plane surface, that is this total surface is a plane surface having width b. B is the width of surface, and this surface has got center of gravity g. G is the center of gravity which is at a distance of h bar from free surface of liquid. So this is the free surface of liquid. We call this as the free surface or topmost position of this liquid. So from this top position of liquid, the center of gravity is at a distance h bar. So h bar is the distance of CG of surface, center of gravity of surface, from free surface. Then we consider small area dA, small area dA, or small strip we consider, which is at a distance h from free surface. So small area we are going to consider for our study purpose, which is at distance h from free surface. So the thickness of this small area is dH. dH be the thickness of small area. Now this point P is the point where the total pressure acts. The point P is nothing but the point at which total pressure acts, and let it be at the distance of h star from free surface. What we are going to consider, this point P is at a distance h star from free surface. Now this vertical line is shown here. This vertical line AB is shown. So this is the side view of this plane. Side view. This is the side view of this plane. So side view of plane looks like a line, and the point at which this total pressure acts is here P, and the point at which this force, that is total pressure, acts at point P, which is at distance h star from the free surface of liquid. Now we will see the nomenclature, where B is the width of this plane. Okay, now we will have the nomenclature. So what is this A? So A is the total area of surface. So whatsoever is this area, so total area of the surface is A. Then G is the center of gravity of plane surface. So G is the center of gravity, as we have discussed, which is at a distance of h bar. So h bar is the distance of center of gravity of area from free surface of liquid. And then this P is the center of pressure. So P is the center of pressure, which is at a distance of h star from free surface of liquid. And we are going to consider small strip area dA, which is at a distance of h from the free surface, where dH is the strip thickness. dH is the thickness of this small strip area dh, and this strip is at a distance of h meters from the free surface, a distance of strip from free surface. Now we'll see this to find out the total pressure on a vertical plane. So total pressure we are going to find out. So now what we see is that total pressure on the surface may be determined by dividing this complete area into small strips. So we are going to divide it into small strips like this, and we are going to calculate small force dF, say, so on each strip, and finally adding all those forces together we can find out total force. So in the sense we are going to integrate. So the force which is acting over this small area, if we find the pressure intensity on the strip. Now first we consider the thickness dh, a small strip. Consider a strip of thickness dh and width b, and at a depth of h from free surface. Now as we have seen, the pressure acting over a surface at a distance h from free surface is given by rho gh. So pressure intensity on this strip So this strip is at distance h from free surface, therefore the pressure intensity can be obtained by rho gh. So already we know rho gh is the pressure intensity at depth h meters from free surface in a liquid having density rho, where rho is the density. So now if we want to find out area of this strip, that is small dA, is given by breadth into thickness of this strip. So to find out small force acting on strip, that is dF, is equal to pressure intensity P into small area dA. So force is equal to pressure into area. So as we are going to find out small force over the small area dA, so small force dF is equal to P into dA. So now we know P is equal to rho gh into dA. So force dF is equal to rho gh into dA. So to find out total force on the strip, we have to integrate this, and by integrating we can get the total force. So total force on the whole surface, therefore the total force on whole surface is obtained, that is F is equal to integration of small df, and that is nothing but integration of rho g h into dA, or this dA is known as b into dh. So integration rho g h into b into dh. So now we can see this rho and g are the constants, So if we take rho g as the constant, we can write this as a rho g integration of b h dh. So now what we know is integration of b into h into dh is equal to integration of h into dA. So h into dA. So h b into dh is dA. So therefore this integration of h into dA is nothing but moment of surface about free surface of liquid. So this small area into this distance gives us moment of this small area or strip about the free surface. So this term is nothing but moment of surface area about the free surface of liquid. Free surface of liquid, that is nothing but area into h bar. So this was for small area, integration of h into dA, this is for small area. If we consider complete area, so center of gravity of this complete area is at distance of h bar. So that can be written as a into h bar. Small a becomes capital A and h becomes h bar. Therefore this equation, say we call this as equation number 1, this as equation number 2, say this as equation number 3, and this as equation number 4, and this as equation number 5. So equation number 4 becomes equation number 4, that is F is equal to rho g and BH dH, integration of BH dH is nothing but A H bar, A H bar. So this is the force or total pressure acting over a surface which is submerged vertically in the liquid. So from this what we can see is, so where rho is the density of liquid in which this surface is submerged, and h bar is the distance of center of gravity of plane surface vertically submerged into the liquid. Now coming to the next center of pressure, where the center of pressure acts. So now here first of all we can see this point P, at point P this total pressure or the force is acting. So if we take the moment of this force about the free surface of liquid, we can find that is the product of F into H star. So where the point at which this total pressure acts, let us assume that total pressure is acting at point P, which is just below this point G, where G is the center of gravity. So center of pressure is calculated using principle of moments, which states that moment of resultant force about an axis is equal to sum of moments of components about the same axis. So there are n number of forces. Say there are n number of forces, 1 2 3 4, so forces are acting, and if we take moment of these forces about the free surface or about the axis, say we take here axis, so if we take moment of these forces about the axis, then the total moment will be equal to the resultant of a moment, moment of a resultant. So instead of taking so many forces, if we take single force which is the resultant of these forces, and if we take moment of this resultant about the axis, so that is going to be equal. So therefore here we are initially considering there are n number of strips, and n number of small forces dF are acting. So instead of taking the moment of all forces, so if we take the moment of single force which we have calculated total force or total pressure about the free surface of liquid, then we get the moment of that force about the free surface of liquid. So about the free surface of liquid. Therefore, we can write the moment of force F about free surface of liquid is given by F into H star. So where this total force is acting at point P and this point P is at distance of H star from free surface. So now this is we call this as equation number 1. Say. Now taking moment of small forces, if we take moment of small force which is acting on this small area, that small force is acting, say for example dF on this small area. So if we take moment of this small force dF, moment of force dF acting on strip about free surface of liquid, that is given by small dF into H. So where H is the distance of this small area from free surface. So H is the distance of small area from free surface. So where we can write this dF as rho g H into B into dH into H. So this dF can be written as rho gh B into dH. So from equation already we have seen. So from this equation 4 we can write this as dF is equal to rho gh, equation number 3. dF is equal to rho gh dA, or that can be written as rho gh B into dH. So we have taken it here. So now from this, the sum of all such forces or moment of forces about free surface to obtain sum of the moments. So sum of moments of all such forces about free surface of liquid we can integrate this above equation, say equation number 2. Integrating equation number 2 we get integration rho g h into B into dH into EH. So this can be written as rho and g are constants. So rho into g integration B into EH into H into dH. So therefore we can write this equation as a rho g integration of B H into H we can write as H square dH. H square dH. So therefore this B into dH B into dH is area that we have seen in previous slide. B into dH is the area. From this equation number 2 we can see the area of strip is breadth into thickness. So therefore, B into dH can be written as a rho g integration of h square dA. So now this h square dA, integration of h square dA is nothing but the moment of inertia of surface about free surface of liquid. Moment of inertia of surface. So this is the surface and its second moment of inertia about the free surface. Second moment is nothing but moment of inertia. So this term is known as moment of inertia of the surface about free surface of liquid. Free surface of liquid, and which is represented by I naught. So therefore, this can be written as rho g into I naught. Rho g into I naught. So this is the moment. So here we have seen two kinds of moments. So moment of total force and moment of small forces. So we have considered only the force acting, total force acting at point P, and small forces acting at various strips. Here we have considered this plane to be made of small strips, and we have small forces dF1, dF2 and so on. So the moment of all small forces about the free surface is obtained by this equation number 3. So now what we can see is the moment of total force given by equation number 1, and moment of small forces, addition of moment of all small forces about the free surface is going to be same. According to the as we see that the moment of area or principle of moments, we can equate equation number 1 and 2. Equating equation one and 3, we get that is F into H star is equal to rho g I naught, or this is the H star. What we want to find out is H star. Our aim is to find out H star. Therefore, we can write this as H star is equal to rho g I naught divided by F. So as we know that F is equal to rho g a h bar, which we have derived. Force is equal to rho g a h bar, which we have derived just now. We can see here. So this force F is equal to rho g a h bar. So we call this equation as the total pressure. This is known as a total pressure. So this total pressure F we have taken here. So replacing this rho g I naught divided by rho g a h bar. So rho g gets cancelled. So we will have I naught divided by a h bar. I naught divided by a h bar. So now we have seen in mechanics that the parallel theorem exists for moment of inertia. Parallel theorem of parallel axis, according to theorem of parallel axis. What is written? I naught is equal to Ig plus of A h bar square. A h bar square. So where I naught is the moment of inertia about one axis which is at a distance of h bar from the free surface. So for example, if we want to find out the moment of this complete area about the free surface, so moment of this area about its center of gravity plus of area into the distance of center of gravity from free surface square. So that gives us moment of inertia about a free surface. So this IO can be replaced and H star above equation becomes H star is equal to Ig plus of A H bar square divided by A H bar. So this can be written as Ig divided by A H bar plus of H bar. A gets cancelled, H bar gets cancelled, only H bar is going to remain. So this H star is nothing but the center of pressure, or it is the distance of center of pressure starting from free surface. So this is the H star. So that is given as Ig divided by A H bar plus of H bar. So what we can understand from this equation is the center of pressure which is at distance of H star. So this H star is the sum of H bar plus of something additional. That is nothing but the center of pressure is always below the center of gravity, because this H star is not equal to H bar, it is at some additional distance from free surface. H bar plus something is H star, so that something is here. Therefore, what we can conclude here is, first point, center of pressure, total pressure, lies below the CG, center of gravity. And second is the distance of center of pressure from free surface of liquid is independent of density. So here the term density is not going to arrive in this equation. So H star is independent of density of liquid in which liquid it is submerged, does not play any role. So what is Ig? Ig is here, it is the moment of inertia about the axis parallel to the free surface passing through the center of gravity. So Ig is the moment of inertia, of area about an axis passing through CG, passing through CG and parallel to the free surface. So Ig is nothing but moment of inertia of this free surface. Say for example, this is a surface which has got center of gravity here G. So moment of inertia about this axis XX, which is parallel to the free surface of liquid. So this is the free surface, then this moment of inertia about the x-axis is known as Ig, and moment of inertia of this surface about the free surface or plane about the free surface is known as I naught. So moment of inertia about the axis passing through the center of gravity of a plane and which is parallel to the free surface is known as Ig, whereas moment of this area about the free surface is known as I naught. Okay, so this is a very important thing where we have located center of pressure. The equation for center of pressure is given by Ig divided by A h bar plus of h bar. So Ig is going to vary. So moment of inertia is going to be vary depending on the shape of plane. So if it is a rectangle, if it is a triangle, circle, parallelogram, tetrahedron, depends. It depends on the plane. Tetrahedron is not a plane, it is a three-dimensional object. So it depends on the type of plane. So now we can see here for a rectangular plane having width b, depth d, the center of CG from its base, so center of gravity is at half of this depth. Then area is given by BD. So moment of inertia about an axis passing through center of gravity Ig is given by BD cube divided by 12. So this is Ig for rectangle. So if we take this rectangle in this way, horizontal way, and this is B and this is D, then that becomes dB cube divided by 12. So if it is taken like this, then it becomes dB cube divided by 12. So if we change these dimensions or this shape, then this is going to change. So this is the moment of inertia about IO. So IO is nothing but one edge. So about this edge, if we want to find out the moment of inertia about this edge, then that is given by BD cube divided by 3. So again similarly, for triangle having base width B and height h and center of gravity is located here at h by 3 distance from base. So this is at the distance of h by 3 from base. So this distance is at h by 3, where the area is obtained by BH divided by 2 and moment of inertia about the axis passing through center of gravity. So this about this line is given by Ig is equal to BH cube divided by 36, and the moment of inertia about the base, about the edge, base edge, about this edge is given by BH cube divided by 12. This is I naught, and moment about this axis is IO, moment about this line is, sorry, Ig here and IO is here. So this chart is given in book of R.K. Bansal, Fluid Mechanics by R.K. Bansal. So similarly for circle also, circle of diameter d, so it has got center of gravity from base at d by 2 and area is given by pi by 4 d square, whereas its moment Ig about the axis passing through its center is given by pi by 64 into d to the power of 4. So for trapezium, similarly the equations are given to find out moment of inertia about the axis passing through center of gravity. So this data can be used to simplify the numericals. Now we'll discuss some numericals here. Very first numerical, so what he says, a rectangular plane surface of 2 meter wide and 3 meter deep. 2 meter wide and 3 meter deep. So a rectangular plane of 2 meter wide and 3 meter deep, 2 by 3, it lies in a vertical plane. So this is vertical in water. So water, this term gives us a data that is nothing but the density for water is 1000 kg per meter cube. So this water word gives some value to us, that is nothing but 1000 kg per meter cube is the density of liquid in which this plane is submerged. So determine total pressure in the sense F we have to find out, and position of center of pressure, that is H star we have to find out. on the plane surface when its upper edge is horizontal. Upper edge is horizontal. This edge is horizontal and coincides with the water surface. Here he is going to have two different problems. When this upper edge coincides with the free surface of water, so if it is submerged into this water, so this edge is coinciding with the free surface. And second case, if this edge is below this free surface is here and rectangle is here, so this distance is given as 2.5 meter. It is 2.5 meter below the free surface. Same rectangle having same dimension. Once it is submerged, but its one edge is coinciding with the free surface of water, and in second case its free surface edge is distance of 2.5 meter from free surface. So now we will see this example. A rectangle having 2 meter width and 3 meter depth and is submerged in a water such that its edge is going to coincide with the free surface of water. In second case, as he has given, it is given that it is submerged in a water in such a way that its edge is at a distance of 2.5 meter from free surface, and the dimensions are going to be same, that is width is 2 meter and depth is 3 meter. So it is submerged into the water. So distance of center of gravity is given by h bar, and here also distance of center of gravity is h bar. So in first case, so h bar is half of this depth. So because it is center of gravity is at 1.5 meter and this edge is coinciding, so therefore h bar is equal to 1.5 in first case. In second case, h bar is equal to 2.5 plus this distance is 1.5. So h bar in the second case is 4 meter. So h bar here is 4 meters. So now we will simplify this. What is given here? Width of rectangle is 2 meter, depth is 3 meter. In first case, so x1, that is the distance, we call this as x distance. So this is x2. In first case it is going to coincide, therefore x1 is equal to 0 and x2 is equal to 2.5 meter. So we have to find out the total pressure and then center of total pressure in first case and total pressure in second case. So here we have two cases. So now in first what we have to find out? Force. So to find out force, we must use this equation rho g a h bar. So rho g a h bar, so h bar can be known. So first case we call h1 bar. In case of first, h1 bar is 1.5 meter. How 1.5 meter? So this total distance is 3 meters and center of gravity is at distance of 1.5 meter from free surface, because this total distance 3 meter, half of it. For rectangle, the center of gravity is at distance of half of its depth. Therefore it is 1.5 meter. Then h2 bar. In second case, h2 bar, so total distance of center of gravity is 2.5 plus this is 1.5. That is nothing but 2.5 plus 1.5, which is 4 meter. h2 bar, in second case h2 bar is 4 meters. So we have two cases. For first case we call as h1, for second case we call as a h2. Then area of rectangle A is equal to B into D. That is, breadth is 3 meter by 2 meter. So 6 meter square is the area. So now we know area, we know h bar. Now we must know Ig. So Ig for this surface is given by BD cube divided by 12, which is shown in this chart. So Ig is given by BD cube divided by 12. Ig is equal to BD cube divided by 12. So what we have to find out is, first we have to find out area, then moment of inertia, then h1 and h2 bar, and we have to substitute in this equation 1 and equation 2. So first of all, for simplification of this problem, we will find out first case, then second case. So in first case, what we have to do is, first we will find out the area. Area of surface is equal to B into D. So B is known, that is 2 meters into 3 meters, which is equal to 6 meters square. Then Ig, moment of inertia, Ig is equal to B D cube divided by 12. So moment of inertia we can find here. B is 2, D is 3 to the power of 3 divided by 12. So this becomes 4.5 meter to the power of 4. Unit for moment of inertia is meter to the power of 4. So now we know Ig, we know area. So case 1, edge coincides with free surface of water. Therefore, H1 bar or H1 H bar can be given as 1.5. So force F is equal to rho G A H bar. So we know rho is equal to 1000, G is equal to 9.8. We can take it as 9.81 meter per second square, into area is 6 meters square, into H bar is 1.5, and after simplification we get force as 88,290 Newton. So for first case F1 we call this as force 1, because we are going to discuss first case. Then H star, center of pressure, is given by Ig divided by A H bar plus of H bar. So we know Ig value is 4.5 divided by area is 6 into H bar is 1.5 plus of 1.5. So if we simplify this, we get H star as 2 meters. Star is equal to 2 meter, or H1 star is equal to 2 meters. So this is for first case. For second case, if we see here, already we know area and moment of inertia. So case 2, in case 2, the upper edge is 2.5 meter below free surface. Therefore, here we can find out H2 bar. Actually it is H bar, but it is second case, therefore we are taking suffix H2. So distance of center of gravity from free surface, so this distance is going to be 1.5 meter. So this is 1.5. Therefore total distance H2 bar is 2.5, that is x2 plus of 1.5. So this total distance of center of gravity from free surface is 4 meter. Now to find out this total force F, total force F is equal to, we call this as F2 now, rho G A H bar 2. So rho we know that is 1000 into G is 9.81 meter per second square, into area is 6, into H2 bar is 4. So this area already we have calculated. In first case area was 6 meters, Ig is 4.5 meters, that already we have calculated. On simplification we get force as 23,000, sorry, 2,35,440 Newton. The force is known. Now H star is equal to Ig H2 star. So second case we are taking suffix as H2 star is equal to A H bar 2 plus of H bar 2. So Ig is known. Ig value which we have seen here is 4.5 divided by area is 6 into H2 bar is 4 meter. So this is 4 meter plus of 4 meters. So H2 star we get as 4.1875 meters. So summary is F1 which we calculated is 88,290 Newton, and H1 star which we obtained here is 2 meters, and F2 force which is 2,35,440 Newton, and H2 star is equal to 4.1875 meters. So this is the answer. In first case we get force and distance of center of pressure. In second case also we get force and distance of center of pressure from free surface of liquid. Now we'll simplify another problem. Numerical 2. Determine the total pressure on a circular plate. So plate is now circular of diameter 1.5 meter which is vertically placed in water. Again water is given, means density rho we can find out. Circular decides Ig value such a way that center of plate is 3 meters below the free surface of water. Find the position of center of pressure also. So we have to find out again force and H star. So now what he says, there is a circle having its center of gravity at 3 meters from free surface, and the diameter of circle is 1.5 meter. So diameter is 1.5 meter. So now diameter is given as 1.5, and H bar, center of gravity from free surface, directly it is given is 3 meters. So we have to find out force and H star. So to find out force we use this formula rho g A H bar, and to find out H star we use formula Ig divided by A H bar plus of H bar. So to find out area we use equation pi by 4 d square, and to find out Ig we use the equation pi by 64 d to the power of 4. So by knowing this Ig and A we can find out H star and F. So to simplify, first of all, area of circle or area of plane A is given by pi by 4 d square or pi by 4 into diameter is 1.5 square. So this, if we simplify, it is 1.767 meter square, whereas we know H bar is equal to 3.0 meter. So to find out force or total pressure, F is equal to rho g A H bar. So rho value is 1000 because the term water is used, into g is 9.81 meters per second square, into area is 1.767, just we have calculated. H bar is 3 meters. So on simplification this force is 52,002. 0.81 Newton. Now to find out H star, we use formula that is Ig divided by A H bar plus of H bar. Ig is not known. First we have to find out Ig. Ig is equal to pi by 64 d to the power of 4. So pi by 64, d is 1.5 to the power of 4. So this is going to be 0.2485 meter to the power of 4. This is Ig. Now we can substitute this data, that is 0.2485 divided by area is known, that is 1.767 into H bar is 3 plus of 3. On simplification we get H star as 3.0468 meters. So this is how we are going to get the distance of center of total pressure and the total pressure F. So answer is total pressure F is equal to 52,002.8 Newton, and center of pressure H star is equal to 3.0468 meters. Thank you. Today we stop here, and in next class we will see few more numericals and the derivation for finding the total pressure and center of pressure on a horizontal surface. Thank you.